In 1941, during active combat operations, German Air Force units captured a Soviet airfield, discovering a significant number of intact I-16 fighters and a stockpile of spare parts. Command decided to use this captured equipment for training purposes to prepare their reserves. However, after just a few weeks operating these machines revealed serious problems. Regular accidents started to occur. Planes crashed on landing, stalled into spins, and lost control during turns. It wasn't just cadets falling victim to these incidents, but highly experienced combat pilots as well. Because of the high accident rate and how difficult they were for untrained personnel to fly, the program using these aircraft was urgently shut down. What is remarkable is that this aircraft was actually designed as a cutting-edge technical solution, meant to be ahead of its time. In the early 1930s, global aviation was dominated by biplanes, which were considered the pinnacle of engineering at that moment. The military doctrine of most countries prioritized maneuverability, viewing speed as a secondary factor in close-quarters dogfighting. Nikolai Nikolaevich Polikarpov held an alternative view on the development of fighter aviation. The chief designer, whose achievements were highly valued by the country's leadership, including Stalin, foresaw a shift in the nature of future air battles. While the rest of the aviation world focused on biplanes, Polikarpov's design bureau was developing a fundamentally new type of machine, a high-speed monoplane fighter with retractable landing gear and an enclosed cockpit. The work was done on their own initiative, since military specialists were initially skeptical about moving away from traditional designs. However, after the first prototype flew, the effectiveness of the new concept became obvious. The plane demonstrated a speed of 250 miles per hour and a climb rate of 200 feet per second, which was an outstanding result for that era. In terms of its tactical and technical characteristics, the new machine surpassed many foreign counterparts, providing a significant technological advantage. Structurally, the fighter consisted of a wood and metal frame with transverse bulkheads and a rigid engine mount. The skin was made of birch veneer, ranging from 0.1 to 0.15 inches thick. On the first versions, the wings and tail surfaces were covered in fabric, which was later replaced with duralumin to increase strength. The first modification of the aircraft, the I-16 Type 4, was armed with two 7.62 mm machine guns, synchronized to fire through the propeller arc. Since the USSR lacked its own powerful aviation engines at the time, Polikarpov initially designed the airframe around the American Wright Cyclone engine, which produced 720 horsepower. Later, licensed production was set up under the designation M25. This became the fighter's standard power plant. During the initial tests, certain operational quirks were discovered. Pilots complained about the discomfort of the enclosed cockpit and the lack of ventilation, so flights were often flown with the canopy slid open. A key characteristic of the machine was its rearward center of gravity, which was intentionally designed that way. This technical decision significantly improved maneuverability in the horizontal plane. A full turn took 16 seconds, whereas its German counterpart, the Bf-109, took at least 23 seconds. However, the price for such high maneuverability was that the plane became much harder to control. The aerodynamic design chosen for the aircraft resulted in instability at high speeds and made the machine difficult to handle during landing approaches. Flying the fighter demanded constant attention, since losing control or making a piloting error could easily send the plane into a tailspin. That said, it was noted that recovering from a spin was relatively easy, provided the pilot knew what he was doing. Some aviation historians believe this layout might have been chosen with future upgrades in mind, specifically the installation of a more powerful, heavier engine that would have shifted the center of gravity. Whatever the reasons, the aircraft proved difficult to master for pilots with low flight hours. This unforgiving handling led to a higher accident rate during pilot training. To minimize incidents, the Design Bureau developed a specialized training version, the UT-4. This variant featured an extra cockpit for an instructor and dual controls, allowing an experienced pilot to correct the trainee's actions during critical moments. Another technical feature defined by the aircraft's design was the landing gear system. Since early models were extremely light, around 3,100 pounds, the landing gear retraction mechanism was manually operated to save weight. Retracting the landing gear was physically demanding and a major distraction. The pilot had to crank a handle 18 full times. This had to be done immediately after takeoff, at low altitude and speed, right when the unstable machine required the most precise control. Complicating matters, the instrument panel lacked indicator lights to confirm the gear was locked up or down, so pilots had to rely entirely on counting the turns. Nevertheless, when it entered service in 1934, the I-16's performance made it one of the fastest and most modern fighters in the world, showcasing the advanced state of the nation's aviation industry. The I-16 was regularly showcased at international air shows and parades, drawing the attention of foreign experts. Given its compact and lightweight design, a concept soon emerged after serial production began to use these fighters in tandem with the TB-3 long-range bomber. The idea was to create a sort of flying aircraft carrier. Attached under the wings, the fighters would escort the heavy bombers on long-range raids deep into enemy territory. If a threat appeared, the I-16s were supposed to detach in mid-air to engage the enemy and protect their carriers. Once the mission was complete, the fighters would use a special mechanism to dock back onto the bomber for the return flight to base. At that time, this technical solution, officially named Zveno SPB, was viewed as quite promising. Engineers explored options for attaching anywhere from 2 to 5 aircraft, placing them above and below the carrier's wings, but they ultimately settled on a layout with 2 fighters under the wings of a TB-3. Unlike many experimental projects from the pre-war years, this complex was actually brought to combat readiness. At the start of the war, a special unit was formed, consisting of 20 TB-3 bombers and 40 I-16 fighters. The unit's mission was to strike ports and oil production facilities in Romania, which was an ally of Germany. The group operated over the Black Sea right up until it was disbanded after losing its airbase in the Crimea. Due to the lack of landmarks over the open sea and the difficulties with navigation, the fighter crews were staffed with experienced naval aviators. The Zveno pilots repeatedly engaged in dogfights with Romanian aviation and air defenses. However, combat experience forced changes to the original concept. After releasing, the fighters returned to the airfield on their own without redocking. To ensure the necessary operating radius, they used a special modification of the I-16 with non-removable wing tanks, which increased flight range from 300 to nearly 600 miles. The development of the I-16 design continued through the successive installation of more powerful power plants. Following the M25 engine, the M62 was introduced, producing 1,000 horsepower, an analog to the Western Right Cyclone R1820. In later modifications, this was replaced by the M63, which boosted power by another 100 horsepower. However, there wasn't a significant increase in speed performance. Top speed only crept up slightly with each new series. This was because, parallel to the engine upgrades, the armament was being beefed up, which naturally made the aircraft heavier. For instance, the Series 17 machines were equipped with two 20mm SHVAK wing cannons with a payload of 150 rounds per barrel. The increase in firepower significantly raised the combat potential of this light fighter. The Type 18 modification is viewed by many aviation experts as the pinnacle of the I-16 platform's development. Equipped with a 1,000 horsepower engine, a variable pitch propeller, and 4 rifle-caliber machine guns, the aircraft could reach speeds of 290 miles per hour in 1938, a climb rate exceeding 3,300 feet per minute allowed it to quickly gain altitude and attack the enemy from above. At the same time, the machine was characterized by its ease of production, simple maintenance, and operational reliability. The first combat application of the I-16 took place during the Spanish Civil War. Over the course of the conflict, about 300 aircraft of various series were transferred to the Republican forces. They were flown by both Spanish pilots and Soviet specialists, who officially held the status of instructors. It was during this period that the tactic of attacking with an altitude advantage began to be used, where the fighter dives on the target, utilizing its reserve of speed. In the first year and a half of the war, the plane held an advantage over the opponent's fleet, which consisted mainly of Italian and German Fiat CR-32 and Heinkel 51 biplanes that couldn't match the monoplanes in speed. The advantage of the new fighters over the biplanes was significant, and the machine earned high marks from its operators. Attempts were made to set up licensed production, but before the Republicans surrendered, they only managed to assemble 12 units, while the rest of the kits remained in warehouses. In the final stage of the conflict, the other side began fielding Messerschmitt Bf-109 fighters, which posed a serious threat. The German aircraft had the advantage in a dive thanks to its aerodynamics and powerful engine, but the I-16 retained superiority in horizontal maneuvering combat. Overall, given the presence of experienced pilots on both sides who knew how to use their equipment's characteristics wisely, there was rough parity in terms of losses in air combat. Neither side could gain a decisive upper hand. Beyond Spain, about 200 fighters, along with a batch of UT-4 trainers, were delivered to the Chinese Air Force. However, due to insufficient pilot training, the equipment wasn't used to its full potential. Japanese aviation, despite lagging behind the Soviet fighter in certain specs, was flown by well-trained crews with combat experience. Consequently, the loss ratio in dogfights often tipped in Japan's favor. The experience gained in the Spanish and Chinese conflicts provided a significant amount of data for future military technical analysis and the evaluation of air combat tactics. The situation didn't lead to the necessary organizational changes. The political purges of the late 1930s affected many military specialists and aviators who had been trying to reform the training system. As a result, by the time hostilities began, Soviet aviation found itself in a difficult position. Despite a significant increase in the number of aircraft, the skill level of the flight crews had dropped. Young pilots had very few flight hours and lacked a firm grasp of group tactics or modern air warfare techniques, which negatively impacted the Air Force's effectiveness after June 22, 1941. At that time, the I-16 remained the primary aircraft of the Soviet Union's fighter force. The grouping in the Western military districts numbered about 1,800 machines of various modifications. It was a massive fleet that, despite becoming gradually obsolete, still retained combat potential. Soviet pilots put up active resistance, but they often lacked practical experience and the skills to coordinate in pairs or flights. In 1941, against the backdrop of technical issues with new fighter types entering service, flight crews in many units preferred to keep flying the well-studied and reliable I-16. The pilots took the tactical and technical characteristics of their machines into account. In level flight, Soviet models of that period were slower than German fighters. However, the I-16 possessed high maneuverability in the horizontal plane, outperforming enemy equipment in this regard. The air-cooled engine was easier to maintain than liquid-cooled motors and served as additional frontal protection for the pilot. The presence of cannon armament and the ability to carry rockets made this aircraft an effective weapon, particularly during head-on attacks. The experience of Captain Safonov serves as an example of how the I-16's capabilities were utilized. He employed maneuver warfare tactics against technically superior machines. In one incident, during an encounter with a pair of Focke-Wulf 190 fighters, he engaged them head-on. The first enemy aircraft was destroyed by cannon and machine gun fire during the head-on approach. Then, taking advantage of the I-16's tighter turn radius, the pilot executed a rapid turn and took out the second machine with a salvo of rockets. The entire engagement lasted less than a minute. The history of air battles records many examples of the I-16 being used effectively by experienced pilots throughout the conflict. With skilled handling, this aircraft could put up a fight even against the enemy's technically superior models. By the time active hostilities began, the machine was considered obsolete, lagging behind its modern counterparts in speed and remaining difficult to fly. Nevertheless, due to a shortage of new equipment, Soviet pilots continued to use the I-16 en masse for combat missions. They operated in conditions where the opponent had technical superiority, which came with a high level of risk and resulted in significant losses of both men and machines. The German Luftwaffe was wary of this type of aircraft, especially when encountering experienced crews. It was well known that in a dogfight, the I-16 had the upper hand in turning engagements against the Messerschmitt. Because of this, Luftwaffe tactics relied on their superior speed and climb rate. They practiced diving attacks followed by a quick zoom climb into the vertical, where the Soviet fighter couldn't effectively chase them. Soviet pilots, in turn, used group tactics and constant maneuvering, trying to drag the fight into the horizontal plane. An effective move was the defensive circle, where several planes followed one another, covering their wingman's tail, making it difficult for a lone enemy fighter to attack without taking return fire. Starting in the fall of 1941, air units began a gradual transition to new types of fighters. It was a slow process because the equipment coming from the factories often had manufacturing defects and required modifications right there in the field. For this reason, the I-16 remained in service for a long time, and on some sectors of the front, it was used until the middle of 1942. Its service life was longest in the Northern Fleet, where weather conditions were extremely harsh. In the aggressive marine environment and freezing temperatures, the I-16's air-cooled engine proved highly reliable, while the new liquid-cooled fighters faced technical failures. The massive radial engine was also noted for its high survivability, often remaining operational even with damaged cylinders, unlike the more vulnerable liquid-cooled inline engines. Returning to base with extensive damage to the airframe and engine was a common occurrence during the operation of the I-16. A remarkable episode involving these machines was recorded in the winter of 1942 on the Leningrad front. With the enemy systematically destroying the airfield network around the besieged city, there was an urgent need to relocate the fighter cover. Since the permanent airstrips were either destroyed or under artillery fire, the decision was made to base the air group directly on the ice of Lake Ladoga. Several squadrons were moved to a temporary ice airfield, where snowbanks and camouflage nets served as shelter. Maintenance on the aircraft was performed out in the open, in difficult meteorological conditions. Mechanics worked in temperatures reaching -22 degrees Fahrenheit. Getting ready for a flight required warming the engines with blowtorches before every start, as well as preheating the oil, which turned thick in the freezing cold. Despite these operating conditions, the fighters carried out their missions, covering transport lines and repelling bomber raids. By the middle of 1942, the I-16 was withdrawn from frontline fighter units as new models arrived, but the type continued to see service. The remaining machines were transferred to ground attack regiments to be used as light strike aircraft. The planes were equipped with small caliber bombs and rockets to strike ground targets like transport convoys, troop concentrations, and field fortifications. The aircraft proved quite effective in this role. Its maneuverability allowed it to dodge flak, and its small size made it hard for air defense crews to aim. Pilots used a tactic of attacking from extremely low altitudes at high speed, which reduced their vulnerability to heavy anti-aircraft artillery, as the gun crews simply didn't have time to track them. Active combat use of the I-16 ended in the fall of 1943. By this time, the fleet was showing significant wear and tear, and spare parts were in short supply, while the industry was already producing a sufficient number of modern aircraft. The surviving I-16s were sent to flight schools as trainers, where they served until the end of the war, although their difficult handling often led to accidents involving the cadets. Thus ended the service life of the world's first mass-produced monoplane fighter with retractable landing gear. Considered advanced for its time, this design saw combat in Spain and China, and took part in the early stages of the Great Patriotic War, becoming a significant milestone in the history of global fighter aviation.